Right, good evening. My name is Robert, and welcome to my OWASP Top 10 talk. This is the something's time I've done it. Weirdly, it's never been recorded, and I really would like a video recorded version of this, especially I'm giving a lightning version in a few days. It'd be nice to share the longer version so people who are interested in the deep dive stuff can jump in and have a look. So, yeah. Let's have a look. I mean, this is a bit weird for me. So I'm using recording software I'm not super comfortable with. This is actually the second time tonight I'm doing this because the first time I ended up recording me talking and doing a whole demo while having a slide on the screen. I'm not very good with these things. But let's see how this one goes tonight. As I mentioned, my name is Robert. You can find me on Twitter unless I've blocked you. Or you can read my blog, which is updated like twice a year, like everyone else who has a blog. And when I'm not avoiding people on Twitter or avoiding writing blog posts, I spend my evenings helping run a conference. It's called DevConf. It's for software developers. It's run by the community and for the community. So all talks are selected by community members. The content is all community driven. There's no sort of vendor marketing nonsense in it. It's really lovely. And I also help run the developer user group, which is a non-profit group that meets in pre-COVID land in 3 cities in South Africa. Now during COVID, meets in one city, meets online once a month, which is fantastic. And once again, it's a place for developers to meet and talk and share. And it's about anything development, which is a lovely experience. My day job, I work at a consultancy called Equal Experts. We're a global one, global consultancy, and we help customers with tough development problems. And when I'm not, and for all of that, I'm based in sunny Cape Town. Although today is very cold and tomorrow will be like that background, wet and annoying. I'm hoping this weekend though, when I go to a game farm to go look at buffalo and zebra and giraffe, it's going to be nice and warm. Hope. Cool. So this talk is about computer security, infosec, cyber security, whatever you're calling it nowadays. I will be talking about how to hack things and explaining and showing demos. And obviously, because we're doing hacking, you have to have your mandatory hoodie. So I have mine. If you follow me on social media or anywhere else, you'll know I normally wear a bow tie. But obviously, if we're doing a talk on hacking, we better wear our hacking clothes. If you have a anonymous mask, please wear that as well for the rest of this talk, because that's the rules, and you just have to follow them. Also, because this is a talk on security and I'm doing hacking, it's probably illegal to do it without permission. So, do this at work where you're allowed to. Don't do this at home where you're not. And one demo that contains the F word in it, I won't mention it, but it will be on screen. If you are of a sensitive age or disposition, please look away. I will let you know when that is. But beyond that, it should be okay. I might say some grumpy words about tech in a bit. Cool. So let's come back here. Slides. Could you move on? There we go. So this is set up around the OWASP Top 10. So the OWASP Top 10 is the guidance, but who makes it? And that is the non-profit foundation called OWASP. They initially were kind of an organization started with web security in mind, but I kind of feel they're all security now, which is really great. They are not aligned to any vendor or company. They're completely community driven, and you can join them as a member, and you should. It helps pay for their staff and what they do. It also gets you a lot of benefits, including conference discounts, which, because of what I do, that's a big thing for me. And whatever you get for your money, or even for not money, if you choose not to spend any money, you get lots from them anyway. You get meetups you can attend. There's a link to the South African one if you're interested. But they also produce tools. There are two that come to mind that I use: Zap, which both of these I'll talk about later, and Dependency Scanner. I also call it Dependency Checker. I don't actually know what the proper one is, but it flops and flips in my head. And so those are tools that help you in your day-to-day. They also produce guidance, and the top 10 is one of those pieces of guidance. It is a list of what the top 10 biggest threats to security out there is. While it is web orientated, most of it will apply beyond web as well. I think there's actually only one that I feel is really web orientated. We're looking at the 2017 guidance. So even though it's September 2020, the 2017 is the current one. The 2020 guidance is actually being built, and you can submit feedback until November this year to improve it. And they evolve their guidance year on year, every few years through this process. And so they'll add items, they'll remove items, they'll even merge things together. And there's a couple I think might be merged in future. And so this top 10 is how you can be exploited, how you can protect yourself. So the guidance they produce is not just like, oh, these are problems, but it's like, how do you detect it? What are examples? Where can you go for more information? What tools are there? And so it really is a very useful place to start. It takes, you're going to watch me talk for an hour to 90 minutes tonight. You could read all of it in an hour to 90 minutes as well. It's maybe less entertaining, or maybe more entertaining, depending on your idea of entertainment. How do they get to the top 10? Well, everyone feeds in, they collect a lot of data about what type of exploits and things are happening. They also score them, on a scale from 1 to 3. And the details are there. So how easy is it to exploit, how prevalent it is, how easy it is to detect, and how hard it is to fix from a technical perspective. And then that produces a list. And the top 10 is obviously the top 10 that we care about. So these are all 10 of them. We'll jump along quickly, but just so you know, we're going to go in reverse order. It's just more fun that way because we start off with 2 that don't have nice demos, and then the rest all have some sort of demo, which is where we'll spend most of our time. So let's talk about number 10. You'll note in the bottom right-hand corner on all these slides, I have the scoring. It's there if you're interested. So what is number 10? It's insufficient logging and monitoring, right? Not logging enough is a problem, right? Log as much as you can. Log every time somebody logs in. Log every time somebody fails to log in. Log every time something abnormal happens. Oh, here's somebody doing a massive transaction. Where did that come from? We don't do big transactions. If you're an online retailer and most of your purchases are like shopping carts of 5 items or less, and suddenly somebody has a 500 item shopping cart, log everything, right? Something weird is happening, right? And that's what this is talking to you. The more you log, the better off you are. Now, don't just log it to a text file on the machine, because that's not going to help either. If an attacker gets access to your machine, then they can edit the logs and hide their footsteps through your network. Exfil that somewhere. Get that to something else. We use Kibana. There are many out there. CloudWatch is another good example from AWS, right? Move it to those. At least there it's writing and it can't be manipulated, it can't be edited. Potentially an attacker can try and overwhelm it, but at least you can kind of pick that up and it's not too difficult. How can maybe you have all this set up, but you turn your logs off for live load tests, or you configure them to ignore pen tests. That doesn't help, right? Because that's what your attacker is going to pretend to do. So really don't manipulate your logs. Leave them running all the time. That might mean you get woken up a little bit extra. It might mean you get an extra PagerDuty alert once a month. It's a lot better than, setting them up and then somebody comes in through the thing you've tried to ignore. And make sure you have alerting on these, right? So logs are good for post-analysis. Oh no, somebody got in. Where did they go? What happened? Where were we vulnerable? What else happened on our network? But alerts on your logs, and if you have something like CloudWatch again, you can get alerts. All right, Google Stackdriver on their cloud, you can get alerts. If something weird happens, wake somebody up. At least they can start to minimize. The quicker you can resolve an issue, the quicker you can be secure. And we're seeing this a lot with ransomware nowadays, right? Initial ransomware attacks, people go onto your network, then they ransomware your whole network, right? So the whole network gets encrypted, nothing you can do. And then they try to get you to buy them Bitcoin to get it back. Now what we see is attackers get on your network and they sit there for a while. And they copy all the data off your machines and they move from machine to machine and try to drop backdoors and make sure they have options. And once they've completely destroyed and got everything they wanted, then they're ransomware your network, right? If you have alerts to pick them up on your network, and logs are an option of that, but things like the Canary from Things, a great Cape Town company, is another great option, right? Detect people on your network and be able to respond to those quickly. So logs are one option, metrics are one option, but really this is an important one to have. Nothing really to show you. It's just good basic stuff to do. More logs, more metrics, safer you are. Have alerts, have people check them. 9 is using components with known vulnerabilities, right? So this is, once again, it's not exciting. This is not, ooh, Robert, you showed me something I've never known. You've known to patch, right? Like everyone always patch your OS, right? You have a Windows box, Windows Update, right? That applies, right? Because if something can get into your OS, they can run the OS permissions. They get into your database, they can get your data. Those are obvious. We know that. Okay, you're smart. You know what I'm talking about. You don't need me to remind you, but you need to remind other people you should be doing this more. But our world of development is different now, right? It's not just like I'm going to go get a Windows box and install it and then have Windows Update and get IT to patch it once a month. I'm probably building Docker containers, right? And put them into like Google Cloud Registry or the Elastic Cloud Registry, right? Who's checking those? Well, both of those services actually offer container scanning that will check those images, right? So make sure you're using that. Make sure, where possible, you're using like the latest versions that you trust of your base Docker images that you build on top of, okay? Make sure that you're up to date in those cases. Use scanning options. Dependency check or dependency scanner, as I wrote on the earlier slide, for JVM-based code is another option, right? So every time before you push code to prod, have it scanned and check, like, are all my dependencies, the code that I rely on, is that all safe? We also have this if you're in the JavaScript space for NPM and for Yarn. You can use audit. .NET has this as well. Why are these important? Well, probably if you're building a modern web app, you're like using Vue or React, those are safe. Like there's enough people looking at it, enough people checking it, but they depend on a library, and that library depends on somebody, and that library depends on somebody, and that goes down a bit, and eventually you get down to like some library that's made by like one individual living in like some country in Europe, and they have a day job, and it's just an idea they had, and they get a like pull request one day, and they check it, like it's working, and it passes the unit tests, and so it goes in, and that has a backdoor, right? And then that flows through into React, and then the whole of React's compromised, and then you pull a new version of React and you're screwed. And that code runs as your code, so it has full permissions, and now you're like completely compromised, right? But you did nothing wrong, except the time it took to go from all the way back there at the farthest ends of the dependency chain to you, it was time for somebody to like catch it, flag up an audit, you get blocked from deploying, and that's what you should be doing, right? That's how you protect yourself. And I think this is going to be a bigger thing. We call these supply chain attacks, and we've seen this happen in the real world, right? Like British Airways had this a few years ago, where somebody determined all their dependencies, then socially engineered a developer on somewhere far down the chain, were able to put code that, when it saw credit card, exfil that data off of the BA website. And it was specifically targeted them. Obviously, they're a big website, they get lots of traffic, but they didn't pick it up, right? How did they pick it up? Did they pick it up with this? No, they didn't. They picked it up with number 10, right? They had alerting and logging on outbound calls. And suddenly there's all these outbound HTTP calls happening, and they're like, hey, this is abnormal. Let's investigate. And that's how they got it. So these all work together. And you'll see me refer to the OWASP numbers backwards and forwards because they do work together. But at least this checks for the things that people will find. The last one in here is, just get code from official sources. Don't get code from like random websites. We have seen people compromise things like Eclipse through a virus, or Xcode through DNS attacks where they redirect the DNS, and so it ends up with some server somewhere. Don't grab that stuff. Like, get it somewhere that you trust. Make sure that the hash of the files you download is correct, because you don't want to download something that's compromised, and then you don't even have a way to pick up, because every build is then compromised, and you're completely screwed going forward. So 9 and 10, really the stuff you know and the stuff I know, and nothing glamorous, but these are, of all the vulnerabilities, both of these made it to the top 10. It's things we all know. Let's get on to stuff with demos and more fun. So we're talking about insecure deserialization at number 8. What is serialization and deserialization? Serialization is I take something in memory, some structure I have in my code, and I turn it into a representation that I can send somewhere. And deserialization is the opposite. I've got some structure somewhere. I've got a nice over-the-wire format, and I'm going to turn it into an object in my code. Practical example of this is, in PHP, for instance, I have an object in memory with some properties, and I turn it into a string and put that into a cookie, so that when you click something on the page, the next time you come through, I can grab the content of that cookie, deserialize it into an object, and then I can maintain state. This has been done forever. There are safe ways to do this and unsafe ways in this. This time, for number 8, we're focusing on the serialization part. Focus on the deserialization. So anytime you take something input, and it's going to be automatically turned into it. So let's jump into a demo. So this is the OWASP shop. I mentioned they produce a bunch of things at OWASP. This is one of them. This is a sample application. It's used to teach you how to hack and how to secure your site. It focuses on the top 10, but I've learned more than the top 10 playing around with this. There are hosted versions you can go and play with. You can download the source code and run it yourself. There are certain attacks that you actually need to have that running locally because you need to simulate like badly set up servers and things like that to compromise. There are also scenarios where, like what I've got here is I grabbed a copy of the code and used it with Heroku. There was literally like a 2-click install, and so you can have your own one up and running, and it's totally free. It takes 10 minutes. You don't have to know anything about anything. It's fantastic. So I've got this one here. It is totally normal. I have not done anything to it. I've literally gone in and I've created an account. So I've got a normal account set up. I've got a credit card added. That literally is, if you go to the site and sign up as a user, add a credit card, that's all I've done. Just to save us a bit of time. And it's beyond that, it's a completely normal, happy experience in here. So we're going to look at this a lot today in terms of like learning how to hack. So let's see what somebody could do. So attackers nowadays are getting smarter and smarter. So they are not just like, just randomly hitting things. They are spending their time learning about how to attack your site and spending time trying to figure it out. So one thing they might do is they might use like a fuzzy URL mapper where they try various URLs that comes to the site. And my browser is probably going to autofill stuff here for me, but they would like put in the word accounting. So they have a tool that will fill in accounting. And then that will generate an error. In this case, it will be a 403, and they'll mark that like this page probably exists, but it's secure, right? And then they'll try a different page like Apple. I don't know if there is an Apple page. Cool, that just took me to the home page with nothing in it. There might be an error here. There might be something in HTTP like a 404. Well, that page loaded. But they'll build up these lists. So and they'll use it to like determine your site, and that could lead them to something like API docs. API docs is a Swagger page, right? Like this is the documentation for using Swagger to represent your APIs. And this is another example of how an attacker can just learn from you doing things you think are good, but maybe give out too much info. So even simple stuff like, hey, this is the new and secure JSON API. Was the old one not secure? I like the new and secure. Like the old one wasn't. But more importantly, like it deprecates the previously offered XML endpoints. It doesn't replace them, it deprecates them. That implies the XML ones are still around somewhere, and potentially they're not secure. We might want to go look for those later. And there is an attack against the XML endpoints if you are playing with the juice shop here. More than that, we can expand these out and have a look at them. You can even try things they set up. This all actually works wonderfully. And if you have a look, here's the schema. It looks totally normal to me. We've got a string, we've got an array here, square bracket, an array with one item in it here. We've got another property with a square bracket, so that's another array. All looks normal, but is it? Let's go take this into the browser console, and let's just paste this in here. It's a little bit easier to read here, I think. And if we expand this out, here is our property we mentioned. Here's an array, there's our square brackets, but you'll note that the data didn't turn into an array. That's because it actually was a string the whole time. But it's a string that contains an array, right? So that's interesting. Like it's double serialized. That implies it's going to be double deserialized, and that's an interesting attack vector, and there is an attack vector on the Juice Shop site with this. It takes a little bit of time to demo it, but I thought I'd show you another way to do it, and maybe play around with a lighter version of this. So let's just say you have a developer working for you today, or maybe they're working alone, and they are trying to build a little prompt on the website. You see I've got some demo stuff here, so we'll call this, let's call this demo. And so he knows he needs to have a property called name and a string in there. Make sure I'm a bit more consistent with my stuff here. With that, right? So that will give him an object called demo, and then he can output it with demo.name. Like, I don't think that's too complicated for anyone. I think we're following along quite happily. You know what I'm doing, I know what I'm doing, and our mythical developer knows what he's doing. And he wants to change this, right, to make the name part dynamic. He wants to be able to pull that in from somewhere and get that into, you know, from a database or something, so you can log it or put it on the screen or whatever. But he doesn't, you know, he's going to have a variable, and like, how does he put a variable in here? Because this is an object. You know, it's not impossible for him to think, like, maybe what I should do is come back to demo here, make the whole thing a string. Maybe that will work. Well, let's change this around a bit. Actually, we should probably use these braces, you know. And it's not impossible to find like Stack Overflow articles that talk about like string concatenation and like adding things together. And if that's what you know, like, oh, I need a string, and then I can work with that. So now I've got a thing called demo, and now I need to turn that into a thing, into an object. So can I do this? Does this work? No, that doesn't work. Oh, what else could I do? Maybe I can just take the whole thing and make it a string, right? Probably need to assign that to something. Let's assign this to Z, and now I can go like eval Z, right? Cool. And now, do I have a demo? I do have a demo object. Let's just make sure this works. Let's change this to something else. Eval Z, and console.log. Let's go find our console.log in the back in history there. Cool. Now it's logging John. So that's working, right? Like, I'm taking a text representation and I'm turning it into object with eval, right? And it's there. Like, I've done what was asked. It's right. It's perfect. Okay. And I don't think that is unrealistic for information you might find on the internet. And now you could just do normal string concatenation. As a hacker, though, I could change that variable that you get, because now I've just run, you know, if this is in a cookie or in a header or something, this piece here, I could change that. And now maybe I put in a function here instead. So function hi, and we'll do curly braces on that. And then if I can get this to, you know, we'll put in console.log as a demo. And let's pop in here hacked as a cool piece of text. And close brace on that. And I need, no, all my typing is gone. Let's do that again. Function hi, so that's a normal function, right? You're happy with that. I'm happy with that. That's an empty function, does nothing. Console.log, escape the tick, so we can print out hacked. Escape the tick and close that. That's a function. It's not going to do anything. Functions don't run themselves. But in JavaScript, you can totally make functions run themselves by you wrap it in parentheses and then put a open close behind it like a normal function. Now it's a self-executing function. As a hacker, you would know this. So that seems fine, right? Like, it's still just a string. And if I eval Z now, note it printed out hacked. It ran this code. I never asked it to run this code, but it ran it. And that's a compromise. I've now been able to use the deserialization function here to run code. And it's not far from people's mind of that to happen. Now, how could somebody protect that? I mean, they shouldn't be using eval, right? They should use something like JSON parse, and if they push in Z, you'll see immediately this thing's already breaking. And if we go all the way back up to like this example up here, Let's go grab that again. Grab that one again. And if I do JSON.parse on demo, that will work. That gives me an object, right? This is a safe way to do it with JSON parse. Eval's an unsafe way. I know this, you know this, but it's not impossible that somebody got bad advice and was rushed and didn't know this, right? These things are easy to fall into traps with. So yeah, I mean, that is exactly how you can example of that. It's very simple, but that's what happens. Now, you might be thinking, oh, you would have to be really basic for that. Here is a screenshot from an article from March of just this year, where exactly this, a deserializing bug in Oracle's logic server. Oracle, owners of TikTok. I don't know why that's important to this, but it feels like that's probably related. And that RCE there, remote code execution, right? Literally what we're talking about. This is not stuff that people stumble across. This happens all the time. It doesn't happen to just anybody. It happens to everyone. You have to be careful, right? So first thing, user input should not be trusted. If you would like to play a drinking game tonight, user input should not be trusted is the keyword. You won't make it past number 3. I promise you that. But yeah, user input, don't not trust it. If it comes from the users, not just what they type, but anything on their side. So we think about what they type in, but cookies come from their side. I can edit cookies. Headers come from the side. I can edit headers, right? Do not trust anything from the client side. Do not trust URLs. Do not trust anything like that. Assume it's all compromised. Okay. If you are going to accept data and deserialize it, there are solutions, right? Safer options. JSON.parse versus eval is a good example of that in the JavaScript space. You can also hash, encrypt, use hashing to sign your payloads or encrypt them. It's even better. So you have a private key on your server side. Before you serialize it to a string, you then encrypt it, send it down, right? When you get something in, you have to decrypt it. If it's been messed with, it will be broken and it won't be able to be deserialized, right? That's a good approach. You could encrypt it and sign it, right? So we know what it should look like, and then you can avoid people like decryption attacks and things like that. There are options here. It is worth your time investigating. It doesn't add a lot of extra stuff, a lot of extra overhead to your life. So that is number 8, the insecure deserialization. Number 7, cross-site scripting. This is probably the most webby focused one, but it's not only for web nowadays. We'll get to that. Cross-site scripting is fairly well known, I hope. Over the years, I think it's become more and more known, but there are various levels of this. So we have reflected attacks. I will show you one of those today. That's where you don't validate input and you send it back to the user, and that allows something to run in the user's context. That's then means the user can be attacked, and code that they don't want runs on their context. It can access their cookies, can access their headers, all that stuff. That's a problem. Worse is stored XSS. So stored XSS, the content gets inputted and then goes into like a database. Now, where is that useful? Well, if I can put code in, right, into like a support form, and then it runs as a support user who might have higher privileges than me, when they view that ticket, that means I can get their privileges, and now I have a support account and I can log in, right? Think back to the Twitter issues a couple months ago where they got in and were able to, post messages from all these accounts, promising all this Bitcoin. How did they do that? Right? They got in not through a cross-site scripting attack, but they were able to post because they had support level in the system, right? If on your support level, people able to do that on your stuff? If so, if I can get XSS into something that they will pop up on their screen, then I can be a support person and have that. And as we build more modern things now with React and Vue, we have DOM attacks. This is like where your API sends something that's going to be rendered, right? You're using React or Vue and you're sending some content from your API, and that's going to be put in with like an unsafe HTML tag, and that gets rendered on the UI. And so an attacker could compromise that in transit and change it, and now it runs there and there's no way to know it. So lots of things can happen. I mentioned the account takeovers, support things, but obviously key logging, being able to bypass like two-factor auth, all of that stuff can happen. It is a big sort of problem. So let's have a look at this quite simply. So we're back on our demo side here. Let's go to the website again. And what I want it to do, once it loads, it's a little bit slow tonight, is I'm going to show you the search feature. We'll pull up the search initially, and in the search, and just having Apple in there. Oh, now it's loaded. Let's not mess with it. In the search here, whatever I type will be outputted on the screen. So, hey, I thought I'd take Apple out and then be okay, but then I hit enter too quickly. So, joys. Yeah, so it'll be reflected back. And then we're going to try and attack it with just some basic cross-site scripting. Right, so hey, website, can I have a search box? Thank you. Let's search for slow, because that's how I feel right now. So you'll note that I put that in the text box there. It's put it in the parameter here. Once again, that's user input, right? That's even though it's in the query string, it is editable. And you'll note that it's outputted the word slow here. As an attacker, has this been checked? So, hey, yeah, that's right. That's my machine going crazy. I am trying to toggle between two things here. Right, so let's go and try copy paste in and a bit of JavaScript, right? So I'm going to pop that in there, script alert 1. And so if I can get a pop-up, if I can get like a JavaScript pop-up on here, I have executed code through a cross-site script. So let's run that. You'll see it comes in here. It's in the URL there, which is great, but it's not being reflected back. I wonder how they did that. How did they know that this wasn't a word? Let's just take out the essence script on that first tag. Oh, so look at that. Alert 1 suddenly. They're doing like matching. So they're looking for the word script, and then they know like, oh, kill the whole thing. And if they don't get that, then they can like strip out tags because they're looking for closing opening tags. Maybe we can put in something that's only an opening tag. Maybe we can do something like that. Oh, actually, it's not even stripping out the tags. The tags just aren't shown because it's pure HTML, right? But maybe we can run something that's not script. So let's paste this in now. This here, and I'll come here for a second. I'll paste it here. It's a little bit easier to read as well. iframe source JavaScript alert. Sure. Boom. There we go. I set the create an iframe and set its source to be JavaScript, and look, now I did an alert. I've just done an XSS. Thank you, Paige. It's that easy to do. So even like that sort of creating approval lists of safe words could be compromised. And there are more ways to do this. We saw this one. This is the basic, obvious one, but obviously our demo site protected us. So we attacked it with this one, but this is another one which looks for like replacement of characters and like lets you strip them out, and then that still runs. Here's another one where it creates a tag that won't be hit. And in this case, it points to an external source, which means that that code can be anywhere. And there are safety nets on these, more crazy options on each of these as you go along. In fact, if we jump back to here, I have a page here on GitHub with loads of XSS payloads. Here's how to do it with video, with CSS, weird XSS vectors that are kind of hard to do, and then lots and lots of really great examples, and you'll see it just keeps going and going and going. Yeah, so you have that. I mean, it's really crazy land, and it gets worse because like this here is one of my favorite ones. This is valid JavaScript. So this is where the one F word is on. I'm not going to say it, but that there is actually a program language. And this program language uses some weird quirks in JavaScript to use only 6 characters, I think it is, if I remember right. So like exclamation and open close brace is in there, plus symbols in there. And it's basically just that to, turn these things into other things. And so you can actually put in here, like, hey, let's do that and encode that, and that's, you can see, it's now spit it out this whole thing. Now the words hacked don't appear in here. The letters for alert don't appear in here. There are curly braces, but they don't. It is a lot to do, but I can actually just run this now, and there you go. Right? It's 11,000 characters. It's not cheap, but it's really hard to defend against that, which is a problem, right? So JavaScript's beauty of like all this flexibility is also like a downside to it. So that can be a problem. How do you protect yourself? Like, do not trust user input. It's that simple, right? If you are accepting content, whether it comes from your backend through an API or database, or and wherever you're going to put it, be it in tags, in headers, in CSS, always escape it, right? HTML escape if it's going to be the page. Escape it in the URL if you're going to put in URL. If you do need to accept input from users and you want rich, plain text is fine, strip out anything that isn't accepted, right? Or use safer formats like Markdown that aren't compromised this way. Where possible, make your cookies HTTP only. So what HTTP only cookies are, they're cookies that are only sent to servers. They are not accessible from JavaScript. Now that doesn't save you from cross-site scripting, because you're still vulnerable, but it means that code that runs with cross-site scripting can't access the cookies. That minimizes your blast radius, and that's why it's really useful. Cause is another good thing, right? So we saw that one example where it could call to an off-site server. Cause will help protect you on that sort of stuff, right? So it prevents like loading content and sending content to places it shouldn't. Cause is a very useful thing. It's a nightmare to work with, but it really is worth your time to get right. CSP is a way of saying what your script should look like. So let's say an attacker is able to either intercept between your server and the user and change the version of jQuery and implement something in there. They might be doing something like man-in-the-middle attack or something like that, or they might be doing some other fancy stuff. CSPs let you sort of say, hey, this is the hash for this piece of JavaScript, and this JavaScript is, if it doesn't match the hash, don't run it. So CSPs are really good for that sort of stuff. It can also limit where you're allowed to run JavaScript from. So once again, really useful and help protect this. And there are plenty of auditing tools. Cross-site scripting has been around for a long time, so it's really easy to detect these things on the web with web auditing tools. So there's really this one's probably becoming less and less an issue. That said, not 18 months ago, we saw cross-site scripting becoming popular again because things like Slack and Visual Studio Code all built on top of Electron, which is web tech, which is vulnerable to cross-site scripting again. So for a long time, I always thought 7 is probably the one that's going to fall away because it's really web specific, but it's now becoming like the desktop attack vector of choice. Because if you can get someone to cross-site, copy paste some code into like Visual Studio Code that causes a cross-site scripting attack, then you could get them to, dump out their GitLab login like token, and then you have access to the GitLab or whatever other extensions they have installed. Fun times. That's why we got to do these things properly. Number 6 is another one that you and I both know. It's really, the stuff we should be doing all the time, right? Let's just get your configuration set up, right? Get your stuff on your servers running in the right way. Only open the ports you need. Don't leave ports open. Only run the services you need on a box. Don't leave, I saw somebody the other day do, they had the Java, remote debugging stuff deployed to prod so that their developers could, have IntelliJ attached to a prod instance. They can work out like crashes with like the IntelliJ tools, and it's like, oh, that's really cool. How do you make sure nobody else does this? So they can't just like sit there and watch everything come through, and now they can have like really nice, you've made it really nice and easy for an attacker. You know, like just plan this stuff out, focus carefully. Don't have things running, services, anything, right? Not having default credentials. How many routers have you got in there? The credentials are the same for everyone who's ever bought that router. Like, it's not hard to do this properly. Have each piece of hardware shipped with a unique username and password. Put on a sticker at least, right? At least it's not in a database somewhere. Error handling, returning too much info is another good example of this. We'll look at that one a bit later though, because I've got a nice demo on that one for something else, but we'll see it, right? And we mentioned using code with vulnerabilities, number 9. It gets re-mentioned here in 6 because it is that big an issue. So let's have a look at the, I keep clicking that button because I want to bring up I have a little page of notes. Right, so this is kind of a weird demo, but it's kind of, at the same time, it's kind of fun. And this is just like, you know, not thinking about your security enough. So let's go to the Deluxe membership. Obviously, this is a online store. Amazon does online stores, and so it kind of copies that in a lot of ways. And this is the membership package. Think of Amazon Prime. And what we have here with the membership package is, hey, I can become a member, and I can get free delivery, and I can get all these sort of things that I want. So we'll click on that button. Bing, boom. When you're ready. Did I click on it? Man, when websites are slow. I want to become a member. Let me become a member. I'll reload you. Oh, no, there it is. Okay. That's what I wanted. It's still loading. Who knows what it's doing now. But this is the page I want. So I can come in here. There's a credit card I mentioned I had added previously. And I can choose other ways to pay. If I had content on my wallet already, I could use a coupon. I could use other payment options. But really what I want to do is get this continue button set up, right? And so as a really simple example, let's go and have a look at that button, right? And we'll click on that button. It brings it up here. And you're going, oh, cool, that's a button. And look, it's got a disabled true. So let's just get rid of that, right? And you're like, I can hear you now. I know you're saying, it's like, it's not going to be this, right? It's not that bad. There's no way that the API isn't checking this, right? The security can't all be just configured on the button. They didn't do that, right? Well, let's see what happens if I click that button. Now that I've made it enabled, haha, you're already a Deluxe member. I have now become a Deluxe member. All the security was on that button. It was misconfigured, right? It's not thinking about the end-to-end. Really simple attack, right? And I'm not using a fancy tool here. I'm just editing HTML. Once again, assume everything comes from the user is untrusted. It is a really simple demo, but I think it's kind of a nice, fun one, right? Do not trust things should come from the user. That includes API calls. They're probably messing around, right? Make sure you get security audits done. If minimum, like every 6 months, get a team in and check your stuff. You're writing a lot of code, get them done. You'll find stuff, right? You'll learn things, and that's important. Get people to go on training. Share this video. You know, it's on you. If YouTube doesn't take this out, like and subscribe, or whatever that means, right? But go and get your teams on security training. Go to companies, get them to teach, pay for things like Udemy courses. You know, learn how to do security. Where possible, automate the checks, right? Right. So you shouldn't be relying on people. They get tired, they get fatigued. Your tester goes on leave. Have things automated so you can like check what's going on, and make sure you remove or block anything that's not needed. You know, don't leave old things. We saw earlier with the API docs. We know there's an XML endpoint that's still available, right? Why is that there? It's not needed. We have a new one. Remove it. Even if you think like, oh, well, we'll just keep it around and won't tell anyone. Like, somebody will find it. People do. So that's number 6 done. Kind of simple one. Let's move on to some more 4. Get back into the deeper stuff. Number 5 is broken access control. So this here is focusing on authorization and authentication. So authentication, auth-n for authorization, authentication, authorization, auth-z. Authentication is about who am I. Authorization is about what I can do. Okay, so normally with authentication is about like, I already have an account on my machine, but I use the broken access control is like I can do stuff in other people's accounts, or I can get information I shouldn't be getting. And these can be as simple as editing URL. The very first system I ever built, that I was ever paid to do in my first full-time job, I built a email reading application. I worked at a hosting company. For those of you who are a bit young, think cloud companies before we called them that. And we had an email server, and we wanted a web front end, and so I built one. And you would type in your email address and password on a form, and it would log you in, and it would check your email and password against the database, and it worked. You can type the wrong username and password, and it wouldn't let you. It was fine. But I didn't remember who you were when you went from page to page, so I put the email address in the URL, and the first person who saw it edited the URL to my email address and then read my email. Like it happened, right? Everything I knew about software development led me to that point, and I just didn't know that, right? This happens to people, and it can happen all the time. We'll see a screenshot in a moment about it, about a particular one. It's called an IDAR, indirect object reference. This is like something like, hey, I have a primary key in my database, and it's an integer. So the first one's 0, and the second one's 1, and the third one's 2, and so on as it goes. So maybe I can just edit the URL if I see a primary key in there. What happens if I change that number from 0 to 1 to 2? Can I see somebody else's account? That's what I mean with that, right? And like, you might not be using something similar like an integer, but you could be using something like a GUID is also not necessarily better. If you look at how GUIDs are made up, like it's a bit of machine stuff in there. There's a bit of like incrementing part. There's a bit of random part, and if you can work out like what the random part is, because you generate enough GUIDs, you can then start to like determine how fast they're going. You work out the incrementing part, and you can actually even attack those. It's obviously a lot harder, not that simple to do, but it is possible. So you got to be careful with like indirect object references. So let's jump back to our demos, and we've got a couple options here. So this one also falls a little bit in the security misconfiguration one, but we'll start off here and pretend our fuzzy tool found this site. So /FTP. Hey, so this hasn't been set up correctly that I should be able to access an FTP server. And there's a whole bunch of stuff in here, and one of them in here is acquisitions. And if we click on that, note this is Markdown. It's not HTML. And note that this is all confidential, right? So this is now like bypassing stuff on the server, and I've now somehow got access to all the information that I shouldn't have as somebody just browsing around. That's just bad website behavior. Bad website. Don't do that again. And it's not hard to do that. That's a simple way of doing it. But maybe we can do something a little bit more interesting. So let's right click on here. Ooh, there we go. Hey, look at that. This little green bar that popped up. That's a challenge I succeeded. We accessed a confidential document. It was that easy. Some of these challenges are easy. Some of them are a lot harder, but that's okay. Let's bring up the network tab for our browser. And you see it's been tracking all the network requests we've been making throughout this. I've got preserve log on up here, which keeps the history going. And so there's, who am I? And there's all kinds of requests in here. Let's just filter this to XHRs and fetches so that I can see sort of like API stuff. And that looks cool. I'm not seeing anything I'm particularly interested about at the moment. Let's clear all this out. And while we do that, let's go back to the website and let's go back to the home page. And what I'm going to do is add an item to the basket, I think. Because what I want to do is kind of trigger the basket code. Because maybe there's a way to view other people's baskets. So let's add an apple juice to the basket. I suddenly thought of something. because I've never gone through all these, but I wonder if these prices are validated on the server. Anyway, here is that. We have 4 requests, Quantisus, something there. There's a search. There's one called 6. I wonder what 6 has got. 6 user ID products, basket items, invalid basket ID. Interesting. Let's have a look at that basket items. It's basket ID. How did it know what my basket ID was? Basket items 401 unauthorized. Hey, basket ID 6, product ID, quantity. Okay, that's interesting. Let's fiddle with this. So what I'm going to do is I'm right click here, go copy, and copy as curl. Copy as curl, not copy all, copy as curl, just the single one. This is available in all your Chromium browsers. I'm going to fire up IntelliJ Postman. I don't need that one. This is just a tool to replay, to create HTTP requests. It's a normal dev tool. You use it when you're building APIs, when you want to test things. But if you have a curl thing, you can go to import raw text and hit paste, and it will paste it in here. And we can import, and there you go. This just makes it a really easy way to copy stuff over and see what's in here. So I can say, hey, basket, oh, that's posting. Let's see, do I have a way? I don't want to post. Can I do, I don't know why it says view another user's basket. I didn't achieve that just yet. Or have I? Cool, so let's have a look here. Oh, there's one that does a get. Let's do it against the get. So we'll do this again. Copy, copy as curl bash. Obviously, I'm on a Windows machine right now, so that's why I've got some other options. Let's import this one, and we'll paste it in here. Cool, so we've got one there. If I just hit send, that will make the same call off. Instead of me having to use the browser, you can see there I've got my thing. And we can now actually look in here, and we can look at the parameters. So this is just an URL. What happens if I change this to basket 1 and hit run? Let's see what happens. Oh, there we go. Somebody else's basket. Indirect object reference to hit someone else's basket. And that's just using normal sort of tools that we have available as a software developer. Really not that exciting there. So let's have a look at that. So we looked at how that can be compromised. The access control is not built. It's like relying on the front end. We saw that with the deluxe membership, we saw it with the FTP, and now we saw it again with the API. And obviously now I could just enumerate each one and get everyone's basket details. So once again, do not trust whatever users give us things in the URL like that. Always deny by default is another good option. So, you know, assume that somebody's wrong and then go and check what they pass you and then only give them access. That's the safe approach. Have rate limiting set up. So if you do have a problem where somebody comes in and they hit the first record and then the second record and then the third record, then, you know, they can get all your data. And I've got a screenshot here. This is from the eThekwini municipality in South Africa, where somebody noticed the primary keys were all in integers in the URL and just incremented each one and got all 100,000 residents of the municipality's details, because by doing that they could view everyone's statements. So it really wasn't that hard. But here's the thing, they don't have rate limiting. If they had rate limiting, it would have at least slowed them down, limited the blast radius. And rate limiting is not complicated to add pretty much to everything nowadays. So it is worth doing. And obviously, once again, basic things, disable web server listings. I once found a vulnerability at a telco, and the way I did that was I stumbled across a web server listing they had enabled, but it also had the version number of the browser of the server, Apache something, at the bottom. And then I was able to use that to go, oh, look, here's the vulnerabilities for that version. And now I can like remote code execute their server and get access, which was great fun, right? So you can get into, you know, limit that sort of information and control that information. Right, number 4 is XML external entities. I kind of feel this is similar to our deserialization at number 8 issue, and I kind of feel this is going to be merged. It's a little bit too specific on XML. It might even just get a name change. But once again, you get some XML in, so we're getting untrusted data in, and then we, instead of using deserialization tools, we use an XML parser. It turns it into an object, but the XML parser, instead of, it's not the become object run code that's a problem. Parsers have features, and those features get exploited. So let's have a look at some of that. Here's one example here. So I've got a XML element foo, and it has a variable called that. I didn't know XML could have variables. Did you? Well, it can. So here's the variable. There's its name, xxe, right? And it gets its value from the file system from this. So if I send this to the server and it outputs whatever's in the XML, it will output the contents of your parse thread. This is a totally legitimate attack against XML. That simple, right? I can see the password file. Here's another one. This is called the billion lols, and this is an amplification attack against the server. So we start off by creating a variable up here called lol, and it has a single string in it, lol. So 3 characters, nothing interesting. Then we create another variable down here called lol1, and it is made up of 10 copies of the first variable, right? So this is just lol, 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 lol 10 times. Happy, right? Then we create an number 2, another variable, and it is points to lol1, right? So this lol1 here is 10 lols. This one is another 10, another 10. And so by the time we finish on this line, we have 100 lols on that line. 3 does the same for 2, right? So each, so this had 100 lines. So this is now 100. So this line's 1,000. And then this line, it does it again and again. And eventually we just output that, right? And so now I've sent a very small payload. This is tiny and easy to go over the wire. And then it causes the XML parser to process this and ends up with with a billion entities it has to process. And then it overloads the memory and crashes the server. And you have an amplification denial of service. Small thing gets amplified to big thing. These are probably going to become amplification attacks, probably more and more attack vector, actually. Maybe not in these ways, but think about microservices, right? A lot of the time you send a small payload in to a service, give me your cart, and it has to make a call to authentication, which makes a call to something else, makes a call to something else. Shopping carts are great examples. You say, give me my cart, and it has to make like all these calls to all the different product systems, right? If you can figure that out, you can do a nice amplification attacks. Shopping carts are a great example of it, because it just spreads out internally, overloads all the back-end stuff, and then you've taken down a website. And you're thinking, well, like this XML, I don't have to worry about it. Here it is in YAML, right? Because if you needed one more reason not to be a fan of YAML and Kubernetes and all of that, here it is again. Exact same, billion lols in YAML. Right, so what should you do? Do not trust user input, okay? This is a fairly specific one around various XML parsers. It is easy to detect with static analysis tools. Sonar is a good example that can pick this sort of stuff up. Your dependency analysis tools are also good for this. Again, we spoke about them earlier. If you have dependencies that use this. Security misconfiguration comes back in this. Internal features you don't need. And explicitly on this one, if you are using SOAP, awesome. More people probably should still. But if you are using SOAP, anything before 1.2 relied on some of these features, which means it's totally compromised. Never trust anything before 1.2. Right, into the top 3. Hopefully you're okay at the 1 hour mark on this. So 3 is about sensitive data being exposed. Things you don't want people to know getting out there, right? These can take the form of man-in-the-middle attacks, as somebody gets access between you and your client, right? They might set up a fake Wi-Fi in a coffee shop, right? And gain access that way. There are obviously more advanced ones with like pretending to be cell phone towers and getting access like in the middle of cell phones. VPNs are very good for that protection on this sort of thing. Getting access to a server or servers in the chain. So, I mentioned like microservices stuff. Like you might have a server that does authentication internally. It's a trusted service, okay? But you have a shopping cart service on the front, like that actually talks out. You know, we talk about BFS, backhand for front ends, is a good example of these type of services, and that we trust those BFFs to not expose stuff they shouldn't from the trusted internal out. But if somebody can get access to that, then they can just like watch everything come through, and they can use that as a vector, and they can abuse the stuff on the authentication server, which now just trusts who calls it and doesn't do real auth against it. Bad cryptography, you know, breaking things can break the cryptography. No hashing of passwords, plain text passwords. I mean, so if somebody does get hold of your database, either they get onto a server and get a copy of it, they find a backup somewhere. You know, we often speak about like S3 buckets being compromised nowadays. Obviously, before Amazon gets the lump of that, but it does happen to Google and to Azure as well, where they, you know, people upload blobs into a bucket somewhere, and then somebody finds it and somebody puts them back up of a database. Okay. Now, if somebody has that and the passwords are in plain text, then they have everyone's username and password, and people reuse passwords. Okay. That's why you have to hash them. So if somebody does get it, they can't get it. They can't turn that into it. So it's not about like, oh, there's no value in it. It's about like limiting blast radius. It's about security and depth. Okay. And lastly, sharing data, which should be private. You know, if I give you something, I expect it to stay with you. I don't expect it to be shared out. So let's have a look at some of this. So let's go back to the website. And let's bring up my account, orders and payments, my payment options here. And I mentioned earlier, I already preloaded a credit card. And we saw when I tried to do the deluxe membership, I had a credit card there as well. And said credit card was, you know, like you saw some of the numbers and then some stars and so on. And we see that here. That's cool. Like I'm not exposing that information, right? My secure data is secure. Or at least I would have hoped it is. Because if we come back to our tools here, hey, here's a web request. Let's go have a look at what came across the wire. Response. And there is my credit card number, right? Hey. We'll move it around eventually, we'll get to it. There it is. Okay, this is obviously a nice HTTP service, right? It's across the wire encrypted, but if somebody can get a service in between, so I mean somebody compromises my ISP, potentially somebody compromises my home network and gets access to my router, they could get this, right? They potentially get a hold of this through clever attacks. It's a little bit harder, like corporate networks where they have trusted root servers set up. It's a lot easier. You know, somebody gets access to a box in your or on your company network and then can fake root certificates so you don't get, and they can break SSL that way, or TLS. I always call it SSL. I'm old. I mean TLS. Break it that way is an option. You know, there are other things like here's, you know, we'll look in the next two how I can gain access to other people's accounts. Here's a good blast radius problem. Like my account gets compromised. Okay, well, I got compromised. They got my username and password from another website that got compromised. And this website does everything right, and they get it in here. Now they've got my credit card details, right? They just pulled it out from the API. Rate limiting again would help on this. Lots of options there. There really isn't a lot to see on that demo. It's a nice and simple one, but it shows the problems, right? So, you know, only store the information you have to, right? The less you store, the less vulnerable you're going to be to attacks, the smaller your blast radius. Encrypt all your data at rest, encrypt all your data in transit, okay? Disable caching of data. I actually had this recently with Twitter. I opened up my Twitter on my Android device, and I got a pop-up that said, hey, we're letting you know we had a security issue. We don't believe anyone's account was attacked, but we're letting you know, and you are safe now. We've updated the app. And I click here to read more, and I go, okay, ooh, that's interesting. What was it? Click there. They cached my token that accessed my account on my phone in a place that was potentially accessible. So if somebody stole my phone, they could get into my Twitter account. If you can get my Twitter account, you could log into some things that might be associated to a Twitter account. I don't think it's anything useful there, but sure. Maybe not for me, but for somebody else, right? We saw people get tens of thousands of dollars just by tweeting through that attack that happened on Twitter. You can do things like preloading, HSTS. Think about anything like 2% of the web's using that, which preloads certificates and helps protect certain attacks against TLS and HTTPS type attacks during the handshaking phase. And another useful part here is just actually take time to like classify your data. Like, what level of security is needed? Is this high risk, low risk, medium risk? What can we do with it? What happens if it gets compromised? It's a really good exercise to just sit down as a team, go through all your data that you store, where you store it, what you need it for, and be able to classify it in write-up docs. And you might actually need to do that for legal compliance reasons like GDPR, but it's going to help your security just as much as well. So it is worth doing. I've got a screenshot of Cambridge Analytica here. That's a really good example of where that fell apart, right? And where it fell apart, my personal data going out. So Facebook built a good API. Hey, here's my details. You can get it. With Cambridge Analytica, I was giving services access to my data. I wanted to do the survey and it needed access to my data. Cool. What I wasn't giving them was access to my friends. But Facebook's API was not well put together. So when I gave you my data, you also got all my friends. And that's how they could get a small number of people's data to do the survey, but then got like 300 million Americans' details. That's that sort of thing. Now, if you do classification and track this stuff and set up your data structures better and think through all of it, you can prevent a lot of this. But it takes time. It's work. Number 2 is broken authentication. So, right, default admin accounts. We've mentioned that before with security misconfiguration. But obviously there are problems. Brute force attacks, dictionary attacks, and credential stuffing. People just like hitting your servers. Eventually going to try and break into accounts. They can get usernames and password lists all over the place now. It's another one, right? And you're actually seeing nowadays like a lot of places like Amazon signs up to Have I Been Pwned, which is a really great website. And they use that to like, oh, we see your email address has appeared in Have I Been Pwned, and that means your accounts could be compromised. We want you to reset your accounts, type thing. Even though they're not compromised, they think your account might be compromised because people reshare passwords. Like they reuse them. People are tired and bored. It's too difficult to have password managers. It really isn't, but for a lot of people it might feel that way. So, they use those attacks. They brute force your accounts, your servers, right? Because you don't have any captures and you don't have any rate limiting. I found a government website a while ago that had no rate limiting, no captures on a API that would get you everyone in South Africa's details from their ID numbers. And ID numbers are mathematically determinable, so I could build a brute force attack and just brute force everyone's ID numbers to get it. And it's a kind of version of an indirect object reference as well. But that was actually used for the rest of the site. That's kind of how you get into the auth. Plain text passwords, I've mentioned before, it's a problem. In fact, actually, I wanted to jump across. I want to show you this one thing. There are websites, like this is from Plain Text Offenders. There's a website that like actually you can go and submit plain text, which websites have it, and they output it. Obviously, I'm in South Africa, I care about this stuff. So, I mean, if we search for COSA, there is lots of them. There's NetFlorist. NetFlorist. That one's been in there since 2011. Yep. I may have been the person who submitted that one. It's, 9 years now, which is great. And as far as I remember, last I looked recently, they still had problems. There are lots of these, right? And if they've got these things wrong here with not doing it, that probably indicates they have other parts of their security wrong and are vulnerable to attacks. So there are like weird problems with that. So let's have a look at how we can compromise that in a demo. So we're going to need the website back. And now we're going to try break into accounts because that's the real fun stuff. Should be over there. Yeah, cool. Hopefully you can see that now. I have no idea what I was showing. I'm sure I was showing the right thing. Maybe you didn't see my slides for 5 minutes. Who knows? I'm not starting again. You can download the slides. from my website. I will write a blog post just for you. Right, so let's go to the login page. Hey, login page. How are you doing? And what I want to do is try to get in here. Now, I may have done some social engineering, maybe try to figure out who's available. I might have logged a support request to the site, like, hey, I can't access my account, and gotten back some people's details. And it's quite possible I figured out somebody who works there. In this case, I could potentially have figured out there is somebody who works there called Bjorn. Now, Bjorn, is an engineer there, and I want to try and get into his account. I know what his email address is, but now I need to get the rest of this. And so, if we put in here, let's put in my email address, and I come down here, hey, tab. So I got email address, tab, yep. You'll see like nothing's happening because it's not registered on the system. But like, let's go put Bjorn's email address in here. There we go. And in a moment, this should fire up. There we go. What is your zip postal code when you're a teenager? Now, the cool thing is Bjorn is actually one of the developers of this OWASP juice shop. He's like a real person. It's not his real email address. But because he's a real person, I could then go off to like Twitter and Facebook and all these places that make these things really easy to find people. And you know what? Where you grew up as a teenager is not complicated to find. So it is actually easy. It is possible to determine where he grew up as a teenager from like actually just searching him on the internet. You'll get that there. I'll leave that to you to figure out. And now we're going to set his password to ABCDE. ABCDE. Hopefully that matches. They do not, because I can never get these things right. A, B, C, D, E. Tab. A, B, C, D, E. Tab. There we go. Change. Cool. And I've reset his password. Right. That's it. That's how hard it is. Now we can go back to login. And what we can do now is we can log in with his account. I actually have never figured out what his real password is normally on this. It would be quite cool. And obviously the big problem here is like somebody might be like, oh yeah, you've got two-factor, right? You have something where you grew up and something you have your email address, therefore that's two factors. That's not what two-factor means, right? This should be doing something better. This should be sending an email to the email address. Hey, have you requested a password change? Yes. Okay, I will take you and let you change it now. I'm not going to send it to you. Yeah, cool. Now I've logged in. My password manager is popping up, asking me if I want to save it. I can click on here and actually see I have his account. And I'm logged in as a support user. I have access to the support tools, which is awesome. So that's one thing. I mean, those password reset things obviously shouldn't send my password to me. That should never be in plain text. It should be hashed, so it can't ever go back to me. But also it should have a thing like, if you did not request it, click here. That should be actually set a flag somewhere and do an alert, right? Going back to number 10, right at the start. Those alerts are monitoring. Somebody's trying to compromise account. If we start to see an account with too many attempts to log into it and it keeps going wrong, flag that. Maybe disable account. Maybe put extra rate limiting on the account. Things like that. The site should have a capture on the login page. This site actually does support two-factor auth. It's under the privacy and security section. There is two-factor auth. Bjorn's account didn't have it enabled. Why does somebody who's in such a high security role not have that enabled by default, right? Maybe you want to do trade-offs with customer experience versus security. For users, that's fine, but you support users, the staff, you don't give them those luxuries. They get two-factor auth. That's not an option, right? So if you just had that, I wouldn't be able to do this. And that really is how easy that one is. So let's have a look at some more with this. Brute forcing it, as I mentioned, there's no rate limit, there's no captures, there's nothing like that. I can download Hydra. It's a free tool. I can use, it's called the RockU password list. It's an old list. And this is all I have to type on my machine to execute it against the website to attack the admin account. We'll get into this a different way in a moment. But that will then brute force the login page until it gets in. That's not complicated to do as somebody on the internet today. That's how hard it is to brute force logins. If you're not doing something to protect your accounts from too many attempted logins, to rate limit, to prevent automated bots, you're going to get attacked this way. So what can you do about broken auth? My guidance: do not build auth unless you need it. Specialist teams help, right? Like if you're in a big enough organization, have a team that focuses on just logins and auth and things like that. It's enough of a job just to keep a whole team busy forever. Look at things like OAuth, right? You can or any other providers at Google or things like that. You can offload that stuff. I've mentioned the credential stuffing brute force. You use rate limits. Look up against the password list from have I been pwned, and don't let users use those passwords because they're bad passwords. You can say like, this is a compromised password. It's probably in a password list like the RockU list, therefore we don't allow it. Forgotten password questions are terrible. Like, try avoid knowledge questions. We've made an entire system in the world called the internet, which is great at capturing knowledge, and then we're building security around on the internet with the idea that knowledge is magic. And more than that, like, it's kind of insidious how that knowledge can be found out. This picture here isn't just like random art. This is a picture I saw on Twitter recently, where it's one of these sort of things that goes around. Like, everyone tweets like, hey, what is your royal name? And it's like, in my case, it'd be, I guess, Lord or Lady. Like, let's be Lady tonight. It sounds much nicer than Lord. I don't feel like a Lord tonight. Lady, your pet's name, Michelle Pfeiffer. That is actually my dog's name. Lady Michelle Pfeiffer, and the last thing I ate. What did I eat? Stir fry. Lady Michelle Pfeiffer stir fry. Yeah, that's who I am. Now what I've done is, when I tweet that out, is I have now associated my actual Twitter account with a string that's easy to pick up with a bot and a knowledge question. Don't answer these things on Twitter. Tell people not to answer these things on Twitter. This is just like sharing knowledge in the most effective way. I can build a bot that just scrapes for this stuff. So easy. Make sure you have two-factor auth where, as much as possible. I know it's potentially a problem for some things, but it is worth having as much as possible. Obviously, plain text passwords don't do that. And if you are going to do, if you have to do passwords, hash them and salt them. So each time they go in, it goes into the database. If somebody gets hold of your database, they can't just brute force it out. But also pick slow hashing algorithms. I know it sounds weird, but there are algorithms for hashing that are designed to be slower. So like SHA-256 is not one of them. And the reason for that is just, once again, that's a form. Oh, come back here. That's just a weird form of rate limiting, right? Like, if it takes SHA-256 like 1 millisecond to hash a password, and it takes like bcrypt 2 milliseconds, you've now got 100% slower logins just because it takes longer with the rate limiting. So you can do these things in interesting ways. There are lots of options there. And then the number one, right? The number one attack for, according to the OWASP 2017 list, is injection. You've probably heard of SQL injection. It is totally a way to do this, right? But you can actually do this not just against databases. You can do this against anything. You can do this against servers. You can do this against code. You can do this anywhere where there's some sort of parser. This is, once again, it's attacking the parsers, similar to things like XSS to the XXEs, to Deserialization, but it's slightly different. And so this, obviously, not necessarily parser. The correct one is that this is attacking an interpreter. And so, once again, we're going to look at it with typing stuff in, but obviously that's just one vector. Anything that comes from a user side is a potential vector. So let's have a look at a demo for this. So let's jump across here, and we will log out here. And what we want to do here is, now we want to get into the admin account of the site. So we've logged out, and this is really suffering today. Let's go to login. And what I want to do is try to get into the account. So there is, for an admin account, it's probably high value enough that somebody's willing to like manually do it. But let's just see what happens here. So I'm going to try put in my email address. I know it's not in the system, and I'm going to put in a fake password, and I'm just going to go hit login. invalid email and password. This is actually a decent one because it doesn't tell me which one's wrong. These actually are attack vectors. There's a website, Adult Friend Finder. If you know what it is, cool. If you don't know what it is, don't worry about it. Just assume it's a site to make friends with, and you never need to go there. It's a site that if you are associated to, it might be compromising in your personal life. And so what happened is they had a forgot password form, just like a login, or no, actually on their password form, forgot password form. And you put your email address in, and it would send you a thing. And they did all the forgot password stuff right. They weren't vulnerable like to knowledge questions, except the error was wrong. If you typed in an email address that didn't exist in the system, it would say email doesn't exist. And if you typed in an email address that did exist, it would say thank you. You check your email. And now I just need to brute force that. Even like maybe I brute force with a bot, but even if I'm just trying to determine like one person or two people, like I want to go after government officials, I can just sit there and manually hit each one. And now based on the error message back, I know if they have an account there, which implies they're users, which implies I can then blackmail them and attack them. So this is quite cool. But let's have a look what happened in the background here. So this tried to call login, and it got a response. There's no JSON or anything in here. It's just some string. It got a 401. It looks kind of normal. So let's go back in here and let's just put in a single tick because that's a thing, right? And let's hit login. Ooh, our error here is object. And we've got another one, bad error handling. So let's go have a look in here now. Boom. Here's a lot of info for us now. What do we have going on in here? I mean, this error, obviously something's gone wrong. This 500 server, it's not failed the login. Something's gone wrong. We know it's running SQLite now from this, right? It's got a whole bunch of stack trace information I could use to determine. Look at all this. Hey, this is probably running on Node because look at all the SQLite Node stuff. That's pretty cool. Hey, here's the SQL query. Oh, and obviously what it's done is just taken the email, whatever I type in there, it's not escaping it. It's not using SQL parameters, it's not doing that sort of stuff. It's putting it straight in there. And so that string is incorrect. So let's play with this string for a moment. But look, it is hashing my password. That's kind of cool. So it's hashing the password I gave it. That's at least secure, or securer. So let's bring this up. It's a nice play to play. So what I want to do here, let's paste this in. So that's a normal line of SQL. And normally we have our password in here. But now what I can do is I can actually go in here. What I want it to do is let me put anything in here. So let's just say I do that. So 1, okay. So where my email is 1, that's not going to be a real email, but that's fine. And password that. So that's this combination of these three pieces. That's not going to be a valid account, right? What I could do here is now say or 1 equals 1, right? So this will always be true. So what will happen here is this, 1 equals 1, so that's false because it doesn't exist. But that will be true. So that becomes true. So that's true, but then it's and the password, which is false again. So because it's an and, they both have to be. So that's false, and then it's not deleted. Okay, so that won't find anything. But I could also in SQL though just do --, and that's now a comment. Everything after this is a comment. So now I've said where the email address is 1, or so this, which is false, or this, which is true. True and false is true. So it is the equivalent of saying, of getting rid of the whole or statement because it's always going to be true. And this is all commented out. So that doesn't apply anymore. So now that's what it's running. All right. So let's have a look at that. So if I go back up here and I'm going to do 1, close my thing, my little quote, or 1 equals 1 dash, that should be a string, 1 equals 1 -- for comment, right? It makes 0 different what the password is because remember that's in the comment part. And now let's run that. Boom, you have successfully logged in with the admin account. And now I have got an account. And if we go, well, that will load. Let's have a look at the network stack while that does its thing. We can actually go to like, who am I? Let's go to this, who am I? Maybe turn off log preservation. Maybe that's just like smashing it too much. there you go. I've logged in as the admin with account ID 1. And even in the actual UI, if I click on that, I'm now logged in as the admin. And that's how you do a SQL injection attack, right? It's that easy. So, as I've mentioned so many times, do not trust things users put in. Never trust it. If you are using something like SQL, parameterized SQL queries are the solution to this. Don't concatenate strings. It's not just SQL. Like, don't concatenate strings anywhere. Like, parameterize things as much as possible. Okay. Avoid whatever, and escape things. Make sure you're not trusting what users are putting in. You can use approval lists to check content. So, why should I allow quote symbols in emails? Like, that's not a valid thing. I can, build up lists of approval things. We can do basic checks like that. Just make it safer. All right. A lot of people talk about, hey, I use an ORM, so I'm safe. I don't use like SQL commands manually. Most ORMs are probably safe because they've been written by people who mostly know, but they've been written by people like me, because I've written ORM and probably many other people have. But you're probably safe, but you should check. And I mentioned Zap earlier. It's a tool from OWASP that is specifically if you're looking for injection attacks and to test your code. It's a really useful tool, and it will help you find these sort of things. So definitely worth using. So if you've done all 10, get through to this. Are you secure? Probably not. You're probably still vulnerable to some things. As I mentioned, this is the minimum bar. This is, if you've got all 10, good. You're in a good place. Now you can build on top of that. Do you not have all 10? Okay, then you have to add more. You've got to get to that 10. That's like the minimum bar, right? Definitely join your local OWASP group. If you don't have a local one, get onto online forums. There are plenty of good groups and options. Go to security conferences. In South Africa, in Cape Town particularly, we have B-Sides once a year. It's one of my favorite conferences of the year, just dedicated to security. Go and learn from people. Go listen to podcasts. Darknet Diaries is a good one. Just experiment and find out different ways of doing things. Make sure you're running your checks all the time. Never take your foot off the pedal for this sort of stuff. Red teaming is a good thing. If you've never heard of it, it's where you, more than just like, I'm going to get a pen test team who's going to like hit my API all the time and throw data at it, and they're going to check that it's how it works and try to break in. Red teams will like try to break into your building, try to like social engineer your staff. It's a really good way to like really find issues, not just in your code, but in every part of your business. Practice this stuff. Practice getting hacked. You're going to get woken up 2 in the morning at some point. Somebody's going to break into your network. Have run books. Have ways of dealing with this. Have ways of responding. And the more practiced you are, the better that it is. And lastly, develop a set of principles for your development teams. This helps plan out work, and having security by default as a first principle is a really good one to go with, because what that does is when you have to make trade-offs, you never trade off against security. You can always then say, our principles are these, and it's like, okay, we're going to trade off unit tests. We always do TDD, but this time we need to ship this in quicker. We're going to trade them off for time. But if security, you can't trade off security, and you have it there and you're reminded, it's a very good behavior. And so with that, I am done. Thank you so much. If you have any questions, feel free to message me on Twitter or email me, or drop a comment wherever I eventually get this posted. And thank you for your time.